This question is from strength of materials for 2 marks. Consider an elastic straight beam of length L is equal to 10 pi meters with square cross section of side A is equal to 5 mm. Young's modulus E is equal to 200 gigapascal. This straight beam was bent in such a way that two ends meet to form a circle mean radius r. Assuming that Euler-Bernoulli beam theory is applicable to this bending problem, the maximum tensile bending stress in the bent beam is dash megapascal. For this numerical answer type question, the accepted answer range is 99 to 101. Let's proceed to the solution. We are given with the length of the elastic straight beam, that is L is equal to 10 pi meters, and Young's modulus is E is equal to 200 gigapascals. It is also given that the beam has a square cross section of side A is equal to 5 mm. Since we know that the length after bending it into the form of a radius forms a circle, the circumference of the circle should be equal to the length of the beam. Therefore, the length is 10 pi, which should be equal to 2 into pi into r, which is the circumference of the circle. From this, we get the radius of the circle as 5 meters. Now, since it is a bending problem, we can implement the bending equation, which is given by m by I is equal to E by r is equal to sigma by y. From this, since we know Young's modulus and radius, we need to calculate the bending stress and we know y. Therefore, considering this part of the equation, that is sigma by y is equal to E by r, we can write sigma is equal to E by r into y. Therefore, we get sigma is equal to 200 into 10 power 3, that is nothing but gigapascal is converted into megapascals, divided by r, which is 5, multiplying into 10 power 3 will give us the radius in mm, into y is nothing but the distance between the neutral axis and the outermost layer. Since the beam has a square cross section, it will be equal to half of the side. So simplifying this will give us the bending stress will be equal to 100 megapascals.